Welcome. Today we will be presenting Thermodynamics ISA 2. We will study about heat transfer and heat cycles. Heat transfer. It is the fundamental concept in thermodynamics and it governs various systems like engines, refrigerators and heat pumps. Heat transfer is basically a transfer of thermal energy from one body to another body. There are three primary modes of heat transfer, that is conduction, convection and radiation. As you can see in the image, the heat is being transferred by all three modes. Conduction. The heat is moving from the body of pot to the handle of the pot. That is, heat is being transferred by solid medium. Convection. The water molecules at the bottom part carries the heat and moves at the upper surface. Radiation. For radiation, there is no requirement of a medium for heat transfer.
Now we will see about thermodynamic cycles. Cycles in thermodynamics are sequence of processes that return a system to its initial state and involve transfer of energy. There are few significant cycles in thermodynamics which are: first, Carnot cycle; second, Otto cycle; third, Diesel cycle; fourth, Brayton cycle; fifth, refrigeration cycle. First, Carnot cycle. It is an idealized heat engine cycle proposed by French physicist Sadi Carnot for a perfect engine. It includes four reversible processes occurring in a cyclic manner. The first process is isothermal expansion process. In this process, the working fluid expands at a high temperature. Second is reversible adiabatic process. In this process, the working fluid expands without exchanging heat. Third is isothermal compression process. In this process, the working fluid compresses at a constant low temperature. The fourth process is reversible adiabatic compression process. In the working fluid compresses without exchanging heat and return to its original state. The Carnot cycle is the most efficient way to convert heat energy into work. Now we will see about Otto cycle. It is an idealized cycle for spark ignition internal combustion engine proposed by Nicholas Otto. It consists of two isentropic processes and two isochoric processes. Mainly, this Otto cycle consists of four processes. First, compression. The piston compresses a mixture of air and fuel in the engine cylinder. Second, ignition. A spark plug ignites the compressed mixture of air and fuel, causing an explosion that releases heat energy. Third, expansion. The increase in gas pressure forces the piston outward as the gas expands. This explosion is the source of the power, turning the crankshaft to generate rotatory motion. Fourth, exhaust. The valve opens the pour out and gas allowed to fresh air in. Fourth process is exhaust. The valve open to pour out the gas and allow fresh air in. Now we will see about the diesel cycle. It idealizes operation of a compression ignition engine typically found in a diesel engine. This diesel engine consists of a 5-step process. The first step is intake. Air is sucked into the cylinder. Second is compression. In compression, compress in the combustion chamber. The third is ignition process. Fuel is ignited into the compressor air. The fourth process is expansion. The hot gas expands and force the piston to move up in the cylinder. The fifth process is exhaust. The exhaust is released. We will see about the Brayton cycle. It is used in a gas turbine engine. It consists of isentropic compression, isobaric heat addition, isentropic expansion and isobaric heat rejection process. The Brayton cycle involves 4 steps. The first step is compression. A compressor turbine compresses the gas adiabatically, means it insulated. The second process is heat addition. Heat is added at a constant pressure. The third process is expansion. The gas expands adiabatically in expansion turbine. The fourth process is cooling. The gas is cooled at a constant pressure. Now we will see about the refrigeration cycle. It aims to move heat from a cold region to a hot region. Refrigeration cycle consists of a 5-step processes. The first step is compression. The refrigerant enters the compressor where it is squeezed and pressurized, turning it into a hot gas. The second step is condensation. The hot gas moves to the condenser where it is cooled and turned back into the liquid, releasing heat into the outside area. The third process is expansion. The liquid refrigerant moves through the expansion valve where it is loses pressure and heat, turning back into cold gas. The fourth process is evaporation. The cold gas moves to the evaporator. It absorbs heat from the inside of the fridge, turning it into a gas. The fifth step is repeat. The gas returns to the compressor to start the cycle again.
Now we will see Otto cycle. This cycle was proposed by Nicholas Otto for spark ignition engine. We can say for 4-stroke engine, like in our daily use petrol vehicles like petrol bike and petrol cars. So there are mainly 5 processes going on this cycle, which are suction, compression, combustion, expansion and heat rejection. Now we will study all these processes in detail, and at the end of the video we will see the comparison of theoretical graph of Otto cycle and the practical graph of Otto cycle. So let's move ahead. First process is suction. We name it as process 0 to 1, where the air is sucked in, keeping the pressure constant. As you can see, the atmospheric air is entering in the cylinder and the volume of cylinder is increasing while piston is moving from TDC to BDC. You can observe from equations like ideal gas equation, when the volume increases, the pressure must decrease. But in our case, we are keeping the pressure constant. This is possible with the help of letting the air from atmosphere enter the cylinder, and we can keep the pressure constant. After suction, compression will happen. When the air is compressed, the piston will move from BDC to TDC. Once the compression is done, combustion will occur. During combustion, an external spark is provided to ignite the air-fuel mixture present inside the cylinder. Now, which makes our engine a spark ignition engine. That means we need to provide an external spark for the combustion of air-fuel mixture present inside the cylinder. After combustion, the process of expansion will happen when the piston will move from TDC to BDC. As you can see, the piston expands adiabatically, means there is no heat loss. You can say no heat is leaving the system during this process. Once the expansion occurs, now we will allow the gases present in cylinder after combustion to go outside the system. Hence the exhaust valve will open and all the gases and the heat is released inside the atmosphere. So these were the processes happening in Otto cycle. Now we will see the comparison of theoretical graph and practical graph. The graph shown in color represent the theoretical graph drawn for an Otto cycle, and the graph shown black and white is the practical graph, like how an actual spark ignition engine behaves during the functioning. So observe in the theoretical graph you can see from process 0 to 1, which is represented in green line, we can see the process of suction is happening where the volume is being increased while keeping the pressure exact same. But when you see in the practical graph, the volume is being increased during process 1 to 2, but the pressure cannot be kept exact constant. You can see there will be some decrement in the value of pressure. This is what happens in a real life engine. It is not actually possible to do suction, which is increase the volume while keeping the value of pressure exact same. There will be some minor deflection in the pressure will decrease a little bit. So in next process the compression will happen where the volume will be decreased and the pressure will increase. You can see those curves which is represented in orange in graph and the shown as process 3 in the actual graph. After that the combustion will occur at the constant volume and the pressure is increasing. Very similar thing is happening in the real life graph also, but the value of volume exactly constant. There will be some deflection in value of volume also. After that expansion occurs and then heat rejection will occur at the constant volume. So you can observe in theoretical graph and in the practical graph there are few things which does not match exactly, but this is very similar to a good extent. So this was for today. Thank you for watching. Please share the video and hit the like.